Good evening, student. Today I'll discuss about important topic which is related to electric current, that is called drift velocity. Before I start about this one, remaining parts there. Now I'll discuss first thing, that is electric current, whose introduction. After that I'll discuss about drift velocity. Okay. So here as you know that potential difference is the difference which is required to steadily and continuously flow of electric charge in a given circuit. तार अर्थ माने कोन, जदि गोटे पोटेंशियल डिफरेंस को आमे रिप्रेजेंट करेबा, जो पोटेंशियल डिफरेंस की कोन करेबो, गोटे इलेक्ट्रिक चार्ज को से कोन करेबो कंटीन्यूअसली एंड स्टेडीली फ्लो करेबो गोटे गिवन सर्किट रे. से जो पोटेंशियल डिफरेंस साधारणतः हमें कोठु पाइबा. ओके, से पोटेंशियल डिफरेंस साधारणतः हमें कोठु पाइबा, सेल बा बैटरी रु पाइबा. ओके, सो जदि हमें गोटे पोटेंशियल डिफरेंस को जे कोनोसी गोटे कंडक्टर को हमें कनेक्शन दबा, ताहले से कोन करिवो. तो पहले चलो हम देखिबा. सपोज इफ यू assume a conductor means what? Conductor is one type of substance. Inside this substance, there are many number of free electrons are there. Okay. Firstly, what do you mean by conductor? Conductor is a substance where it carry electric current easily. Okay, that type of substance called conductor. You know, inside the conductor, many number of free electrons are there, and they moves randomly with certain velocity. That velocity is given by 10 to the power 5 meter per second. Okay, in which region they move in randomly? Particular region is there. That particular region is when a substance like a conductor which is placed near the thermal temperature, then the atom inside the conductor, they absorbing energy from that thermal temperature, so that electrons get released from that atom, so they becomes free. That's why inside the conductor there are many number of free electrons are there. Now that conductor which is connected to a battery, this is the battery, the symbol is like that, which contain two plates. One plate is higher plate, other plate is smaller plate. That higher plate which is represent as positive terminal, and lower plate which is represent as negative terminal. Okay, now that battery which is connected to conductor by using wire, so that becomes plus, so that also plus, and that becomes minus, so that becomes minus, because wire is attached to that conductor. Okay, that's why, as you know, in before topic you know about electrostatic, you know, electric field always moves from higher potential to lower potential. So in that case, which one is the higher potential? Always positive consider as a higher potential, and negative consider as a lower potential. That's why electric field moves from higher potential to lower potential externally. So this is the external electric field which is applied on that given conductor. Clear? Due to external electric field, what will happen? The electrons which are free inside the conductor, okay, due to external field, they becomes move opposite to that of electric field. What? Opposite to that of electric field. Why? Because there is a force which is exert on that charged particle. That force is known as electrostatic force. You know, in before class, some madam or sirs, they are discussed that there is a electrostatic force is there. That electrostatic force experience a force on that charged particle and attract to it. If the charged particle is negative, then the force which is experienced on that charged particle, which is opposite to that of electric field. That's why electron is a negatively charged particle, so that they moves opposite to that of electric field. Clear? In that direction. Here, and while the electron accumulated on that region, there is a positive terminal which is connected to that battery. That's why electron always attracted toward the positive terminal battery and moves toward the higher potential or positive plate. Similarly, at that same time, the remaining part of electron, that means holes, which is always moves opposite to that of electrons. Hole means what? That is the positive type of charged particles. So that the positively type of charged particle, that means positive ion. If electron removed from that atom, then what will happen? That becomes as a positively charged particle. So that the positively charged particle which are moves toward the negative terminal of battery. You know, when the positive charged particle moves toward the negative terminal of battery, and that positive charged particle which is along the direction of electric field, that means this is the direction of electric field and positive charged particle moves in that direction, so that there is a current which is generated. That current, it is dominated by I. That is known as conventional current, and always we represent that current known as electric current. And that electric current which is opposite to that of electrons. And if you represent in the concept the electron which are moving, so they generate also a current, that current known as electronic current. That electronic current always opposite to that of conventional current. Is it clear? So here this is the current. So from above consideration, we have concluded that there are two types of current is here. Here, first one is electronic current. What do you mean by electronic current? If electrons are moving opposite to that of electric field, then which gives a current known as electronic current. Second definition is conventional current. So what do you mean by conventional current? If a positive charge particle moves along the direction of electric field, which gives a current known as conventional current. Clear? So there are two definitions is here. So फिले ये जो इलेक्ट्रॉनिक करंट तमे साधारणतः ए टॉपिक रे न पढ़ी कि तमे इलेक्ट्रॉनिक्स चैप्टर रे पढ़ियो. ये जो conventional current which are related to electric current, so they are become similar in nature. Now I'll discuss about drift velocity. So this is all about classical representation of electric current. Clear? So please note it. Now I am going to discuss about drift velocity. Before I start about this one, you know about isolated conductor. What do I mean by isolated conductor? You know the characteristics of electric flux. Okay, there is a one thing is there that is called conductor. Inside the conductor, electric field is zero if the conductor becomes isolated. That means what? Suppose this is the conductor. This is the conductor. Okay, this is the conductor is here. Whenever that conductor is placed inside the electric field, so this is the electric field. That is the external electric field. Clear? Whenever that external electric field is here and the conductor is present inside it, then what will happen? You know, inside the conductor, many number of free electrons are there. When the external electric field given to that given substance, then the electrons which are present inside the conductor, they becomes repel to opposite to that of electric field, and they are accumulated one end of the conductor. Oppositely, holes are present. That means positive type of charge particle which are present or accumulated other end of the conductor. Clear? So inside the conductor there is an induced electric field becomes generated. So we know electric field is a vector quantity. That's why the total electric field becomes zero. How? You know, external electric field which is opposite to that of induced electric field. Induced electric field. Therefore, the net electric field becomes zero inside the conductor when the conductor behaves as an isolated conductor. Otherwise, it could not be zero. Okay. So this is all about isolated conductor. Clear? Now that conductor, if the conductor becomes isolated, then electric field, external electric field, which is equal to negative of induced electric field. That's why total electric field inside the conductor becomes zero. Now I am going to drift velocity. Okay, you know about all these things. Please listen carefully. Okay, and note it. So next topic is drift velocity. So what do I mean by drift velocity? Okay, and this is the very important long question for your board exam. Okay, now I am going to a topic that is called conductor. Okay, so this is a conductor. Now we know that isolated conductor, inside the conductor electric field becomes zero. Okay, so पहले मु आपको theoretically represent करोचे तमे आपको pause करिके note करो. So here let us take a conductor. Clear? Inside the conductor there are many number of free electrons are there. Free electrons are there. they moves randomly. So this is the free electron that moves in that direction. That is the free electron that moves in that direction. That is the free electron that moves in that direction. That is the free electron that moves in that direction. Yes. So they move randomly in a zigzag motion with velocity 10 to power 5 meter per second. Clear? Please note it. So this is the conductor. Inside the conductor there are many number of free electrons are there, and that is only possible while it is placed at room temperature or thermal temperature. At thermal temperature. Clear? So, okay. Now, that conductor which is attached to that a battery by using wires. The two end of the conductor which is attached to the battery by using key, whose potential difference is V volt. V volt, because potential whose unit is volt, and it contain higher potential and it contain lower potential. Okay, that means there is a difference in between the two potential is V volt. Suppose you have to represent that is V volt and that is 0 voltage here. So there is a difference in between them is V volt. Okay. So whenever we connect the battery to that given conductor, then what will happen? Before connecting battery, the electrons are moving with certain velocity. Okay? Okay, clear? Moving with certain velocity, so that the initial velocity become as u1, u2, u3, u4 before connecting battery. Clear? Therefore, the net average initial velocity of the electrons inside the conductor before applying battery is what? 0. Okay? Why? Because this is the electron moves in that direction. Second electron this moves in that direction. Third electron that moves in that direction. Fourth moves in that direction. So all this electron accumulated in a center region or given a particular region, the net average initial velocity becomes what? That is 0. Clear? Okay. Here the electrons moves with certain velocity so that their net average what? Initial velocity becomes U average equal to U1 plus U2 plus U3 divided by n dot Un equal to 0. Clear? This is the question number 1. Now, if we connect a battery to that given conductor, here we write that thing. Now, we connect a battery to that given conductor. Okay? So that free electrons are moving towards the positive terminal of battery. Okay, due to electrostatic force. Okay, applied on the given charge particle. Clear? So here, when we connect battery to that given conductor, so that free electrons are moving toward the positive null of battery due to electrostatic force applied on that given charge particles. Clear? So please listen carefully. There is a deep concept is here. Okay? Please note it. After that, I will discuss several things. Clearly? Now I will erase that thing. Sorry. So U average, this is the velocity is a vector quantity. So here we choose a vector in that given equation. Clear? So note it. Now I will erase that thing. Now I will draw another diagram, that is the without attaching battery. This is the given conductor is here. So here the free electrons are moving in that direction, in that direction, in that direction, in that direction. This is the free electron. Clear? Okay. If we attach battery, before attaching battery, the free electrons moving randomly and they collide with each other. Okay. Clear? With second high velocity. Clear? That is about 10 to the power 5 meter per second. While we attach the battery, then what will happen? The force which is exerted on that charged particle. So that force which is exerted on that charged particle behaves as a negatively charged particle. So they attract that electrons opposite to that of electric field toward the positive battery. So while that electron moving in that direction, due to attaching of battery, what will happen? The electrostatic force experience a force on that charged particle and they retrace there in that direction. Clear? Okay. Similarly, that charged particle moving in the direction, that charged particle moving in the direction. Clear? Due to electrostatic force exerted on it. Similarly, the charged particle moving in that direction, that charged particle due to electrostatic force, that charged particle moving in that direction. Clear? That means what will happen? तो पिले मन रख पूर्व कौन होता चार्ज पार्टिकल रैंडमली मूव करते जो इलेक्ट्रोस्टैटिक फोर्स लगाला से कौन है से चार्ज पार्टिकल ए डायरेक्शन जा कथा से चार्ज पार्टिकल कौन है तार डायरेक्शन को चेंज कर देला काहे कि गोटे बल ताको टाणुची से बलटा किए इलेक्ट्रोस्टैटिक फोर्स तो टाणिया द्वारा तार जो वेलोसिटी कौन होगा किसी मात्रा रे स्लो हो गला डिक्रीज हो गला केतर के थिला 10 to the power 5 मीटर पर सेकंड थिला एबे केते गेला 10 to the power -4 मीटर पर सेकंड 10 to the power -4 मीटर पर सेकंड हो गला दैट there is a path is obtained that means this velocity becomes in the direction along the positive terminal तारथ ए वेलोसिटी इलेक्ट्रॉन ए दिगरे गति कला बेले जेतोला में गोटे बैटरी लगे देले से वेलोसिटी कोन कला तार अपोजिट दिगु को से टाणी देला कि फोर्स तो पार्टिकल आसी ए दिगरे पहुंच गेला क्लियर सिमिलरली ए पार्टिकल ए दिगरे गति कला बेले गोटे फोर्स ता कोन कला ए दिगरे टाणी देला तो देयर इज ए displacement is here there is a second displacement is here this is also this is a second displacement is here clear and that electron which collide another electron okay पूर्वरु इलेक्ट्रॉन ए दिगरे जिबा कथा किंतु फोर्स द्वारा ये कोन हे गेला ए दिगरे चली गेला जदरे कि से जो इलेक्ट्रॉन टा किछि दूरता चेंज कर देला जदरे कि तार वेलोसिटी ता कोन हे गेला डिक्रीज हे गेला सो दैट इलेक्ट्रॉन ड्रिफ्टेड ताको कहबा हम कोन कहले से इलेक्ट्रॉन ता कोन हे गेला ड्रिफ्ट हे गेला ए दिगरे जिबा कथा से कोन हे गेला ए दिगु चली आसिला आसी कि एई थिबा इलेक्ट्रॉन को से कोन कला कोलाइड कला क्लियर सिमिलरली ए दिगरे जिबा कथा इलेक्ट्रॉन जाय कि ए इलेक्ट्रॉन को कोलाइड करिया बदल रे से कोन कला फोर्स जोगु तार पाथ रे चेंज हेकी ए दिगरे जाय कि गोटे आउट इलेक्ट्रॉन को कोलाइड कर देला इज इट क्लियर सिमिलरली ए दिगरे इलेक्ट्रॉन जिबा कथा जेहेतु फोर्स पाई कि बैटरी जोगु से कोन कला ए दिगरे चले जाय कि इलेक्ट्रॉन को कोलाइड कर देला दैट मींस दैट इलेक्ट्रॉन्स becomes drifted towards the positive terminal of battery तार तो बैटरी जोड़ अछि से दिगरे से मूवमेंट कला देखो ए जाउतला पाथ रे चेंज होला तार तो ड्रिफ्ट this is the drift is here so drift velocity means what drift velocity is the net average velocity with which free electrons are get drifted toward the positive terminal of battery clear so clear this is the electron is here electron and this is also electrons तो पिले पूर्व ए इलेक्ट्रॉन जाय कि आकु धक्का करे बदल रे जेतला हम बैटरी लगे देले तार फोर्स जो ये कोन कला ए इलेक्ट्रॉन जाय कि आकु धक्का कला तो एमान को भितरे किछि पाथ कंसीडर हला से पाथ को कोआ हला मेन फ्री पाथ बोली कोआ हला जेतेबे ए इलेक्ट्रॉन आकु जाय कि कोलाइड कला तो सेति बेले से किछि दूरता ट्रैवल कला ता पई से किछि टाइम लला से टाइम को कोआ गला रिलैक्सेशन टाइम बोली कोआ जो पाथ रे से ट्रैवल करी कि जाय कि अनदर इलेक्ट्रॉन को कोलाइड कला ताको कोआ गला मीन फ्री पाथ जो वेलोसिटी रे से जाय कि कोलाइड कला से वेलोसिटी कोआ गला drift velocity is the net average final velocity with which free electrons are get drifted toward the positive terminal of battery whenever the electrons moving randomly while we attaching the battery then there is a force which is exerted on that charge particle so that the charge particle get drifted before connecting battery they moves randomly and collide with another electron while colliding that electron while we applying the battery that electron collide another electron in that direction. That means that electron drifted with certain velocity and that velocity becomes gradually decreased and they moves toward the positive number battery. Clear? So here you write that thing. Drift velocity. It is the net average velocity with which free electron get drifted towards the positive terminal of battery. Clear? Clear? So, average final velocity is given by average final velocity V average equal to, according to kinematics, V equal to what? U plus AT. What? V equal to U plus AT. So we consider for first electrons. So final velocity of first electron, that means V1 vector equal to U1 vector plus A into T1. Clear? A is the acceleration of that electron. Clear? Similarly, the second electrons whose final velocity is given by V2 equal to U2 plus A vector into T2. Vn vector equal to Un vector plus A vector into Tn. So, net average velocity is denoted by Vd. Vd means drift velocity or average velocity, or V average velocity equal to V1 vector plus V2 vector plus Vn vector divided by n, number of electrons, which is equal to what? U1 vector plus U2 vector plus Un vector divided by n plus A into A vector into T1 plus T2 plus Tn is here. Clear? Please note it. Now I'll erase that thing. Okay? So drift velocity Vd equal to, or V average equal to what? V average equal to, आमे लिखि परिबा कोन लिखि परिबा U1 vector plus U2 vector plus Un vector divided by n plus A vector into T1 plus T2 plus Tn. Clear? That means V1 plus V2 plus V3 plus Vn divided by n can be represented as a V average vector or Vd vector. Clear? So as you know that from equation 1, the net average initial velocity before applying battery is of free electron is 0. Already I have given in equation 1. So Vd equal to vector equal to, that becomes 0 plus A into T1 T2 plus Tn, represented as a net average time. That net average time called relaxation time. What? That is denoted by tau. Okay, here Vd vector equal to what? A vector into tau. So here Vd equal to drift velocity, A equal to acceleration of electrons, and tau is the relaxation time. Relaxation time. Clear? And it is denoted as tau equal to T1 plus T2 plus dot 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 Tn. Now here that is T1 plus T2 plus dot 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 Tn divided by n is here. So here tau equal T1 plus T2 plus Tn divided by n is here. So that is called relaxation time. Okay, so it is denoted by tau. What? Tau. So what done by relaxation time? So relaxation time is the net average time. Relaxation time. So relaxation time, or it is the time, it is the net average time with which there is a collision between two successive free electrons. There is a successive free electrons. So relaxation time means it is the net average time with which there is a collision between two successive free electrons. Clear? So what is my relaxation time? Suppose here we consider, so this is the time. Sorry, so suppose this is the electric field, that is positive terminal is here and that is negative terminal, that means battery if you connect it. So this is the free electrons. Okay, this is the free electrons. That electrons collide with that electron before applying battery. After applying battery, that electrons moves in the direction. While it moves in the direction, while you connect battery, that electron moves in that direction. So there is a drift is here. This is the drift. Similarly, this is the electron. This electron, before connecting battery, that electrons moving randomly in the direction. While we connect battery, that electron moves in the direction and collide that electron. So there is a drift is here. Similarly, all things are there. That electron moves in the direction while we applying battery, that electron moves that electrons. So relaxation time means while that electrons traveling with certain path and collide with that electron, so there is a time which is generated. That time is known as relaxation time for all particles. If we assume there are number of free electrons are there while we applying battery, so that they collide with another electron for a particular time, that time is known as relaxation time. So relaxation time is the net average time with which there is a collision between two successive free electrons. Okay, that means this is the electron while moving in that direction and collide that electron with a certain time. That time for all particles, that time is known as relaxation time. Here another definition is here. While that electron collide another electron, so that it travel a certain path, after that they collide another electron, that path called as mean free path. What? Mean free path. Mean free path means it is a path with which free electrons are get diffused each other, or there is a successive collision between two electrons while traveling a path. That path is known as mean free path. So please note it. After that I'll discuss about mean free path and I'll write that thing clearly. Please note it. This is equation number 2. Okay, note it. Here mean free path. mean free path. So what do I mean by mean free path? It is a path. It is a path in which there is a collision between two successive free electrons. Clear? That means what? Suppose this electron is here. Before applying battery, that electron collide that electron. While we applying battery, that electron drifted their path. So that electron moves in that direction and collide another electron. So there is a path is here. That path is known as mean free path. While they cover a time, that time is known as relaxation time. So mean free path means it is a path in which there is a collision between two successive free electrons. So this is also a free electron, that is also a free electrons. While we connect battery, that electron collide that electron by traveling certain path. Okay, clear? Similarly, that electron collide that electron by traveling certain path, that is known as mean path. Similarly, that electron traveling in that path and collide that electron, so that path is known as mean free path. Or they create time, that time is known as relaxation time. And drift velocity means what? Suppose this electron collide that electron before applying battery. While we connect battery, that means battery means there is an electric field is here across the conductor. Then what will happen? Then that electron moves in a certain path. This is the path and collide that electron. So there is a drift is here. There is a drift is here. Due to drift, all the electrons which are attracted toward the positive null battery. Clear? So that velocity is known as drift velocity. So drift velocity is the velocity with which free electrons are get drifted toward the positive terminal of battery. Okay? So whenever we are applying a battery here, when there is a battery which is connected to that given conductor, okay, so that a force, a electrostatic force which is exert on that charged particle. Charged particle means what? That means electron. Therefore, force due to electric field, that means electrostatic force. Force due to electric field equal to, we know force equal to charge into electric field. Q into E. Q into E. Here, this is the definition. So Q means what? That means, that implies F equal to, Q means what? That is the electron. So electron has negative charge particles, so minus is here into electric field is here. Clear? Now, as you know that force equal to mass into acceleration, therefore it has, that electron has some acceleration. So m into A into E vector, that implies A vector equal to what? Minus E vector by m is here. So this is the equation number 3. Please note it. Now we put equation 3 in equation 2 we get. Clear? So equation 2 becomes F equal to what? That means drift velocity Vd equal to what? Which one is there? That means A into A vector into tau is here. So Vd equal to A vector means what? That means minus E vector by m into tau. So this is the drift velocity. So the formula of drift velocity is given by minus E by m into tau. As we know that the relation between potential and electric field, that is also represented as a potential gradient, that can be discussed in potential chapter. Okay. So due to generation of electric field due to some potential, so there is a relation in between potential and electric field. This is equation number 4. Equation, the relation between potential and electric field or potential gradient, or it can be represented as a potential gradient, is given by E vector equal to what? Minus dV by dr. dV means potential, dr means displacement. So it also be represented as a dV can be represented as a V and dr can be represented as L. Minus sign is here. So electric field can also be represented as a minus V by L is here. So this is the equation number 5. Using equation 5 in equation 4 we get. Using equation 5 in equation 4 we get. So here using equation 5 in equation 4 we get. So what will happen? Drift velocity Vd equal to minus E. E means what? Minus V by L is here divided by m into tau. So drift velocity equal to what? That is EV by ml minus plus EV by ml into tau average. What? EV by ml into tau average. So drift velocity of depends upon electrons, free electrons, and potential, which is potential difference, which is effort on that given conductor, and that electron has some mass, and also depends upon the relaxation time. Clear? So here Vd equal to drift velocity of free electrons, E equal to charge of electron, V equal to potential difference, m equal to mass of electron, L is equal to length of conductor, and tau equal to relaxation time. Relaxation time. Okay. So this is the two formalized here. That is what? That is here Vd equal to minus E by m into tau, and another formula is EV by ml into tau. So please note it all these things, and by heart that two formula. Okay, so this is all about drift velocity of free electrons. What do you mean by drift velocity? Drift velocity is the velocity with which free electrons are get drifted toward the positive terminal battery. That means if we applying a battery so that it produce a potential difference across the conductor. Due to potential difference, there is an electric field which is applied on that given conductor. That electric field behaves as a external electric field. Okay. So before applying battery, what will happen? There is no electric field is here, so that that electrons are moving in zigzag motion and they collide with each other. While we applying battery, that electron while we are applying battery, that electron moves, that electron collide with each other. So there is a path is here in between the electrons, so that we can say that there is a drifting of electrons. There is a drifting of electrons are there, and they move with certain velocity, and that velocity becomes gradually decreases. Before applying battery, there is a huge amount of velocities are there. That is about 10 to the power 5 meter per second. After applying battery, the velocity becomes gradually decreases. It is about 10 to the power minus 4 seconds. And they attract toward the positive null battery. So, please note it. Drift velocity is the velocity with which free electrons are get drifted toward the positive null battery. So, in that case, three definitions are there. One is drift velocity, second one is mean free path. Mean free path means what? It is a path where there is a collision between two successive free electrons. Similarly, it is the time to which there is a collision between two successive free electrons. That time is known as relaxation times. So there are three important definitions are there. They are each having 2 marks. Okay, and this is the some parts of drift velocity. Okay, next class I'll solve the relation between drift velocity and electric current, as well as mobility of free electrons. Okay, so thank you to all. If any doubt, then ask me. Bye bye.